Welcome to another Great Cow BASIC tutorial. I'm covering the PIC18FxxQ41 chipset, and today we're doing part 3, analog to digital. As I said, this is a set of tutorials. I'm going to be covering 19 different subjects, and today analog to digital, or ADC. What am I using here? I'm using a microchip low pin count demo board. It's the little green one. I can show you that very briefly. Here it's flipped away and it's flipped around the other way, but essentially it's got a very simple programming. We're programming this chip here to control the LEDs and the potentiometer, and later a switch. The layout looks like this. I put this on there because it's quite important that you can reproduce this board. As I've shown you yesterday, these boards are available on the internet. There's many different versions of them out there. These are clones, but they're quite useful. And I'm hoping to get a sample from Microchip of a curiosity board before the end of session 19. So what we're going to be doing today, in reality, we're going to be connecting to the potentiometer. So let me just draw a little mark here. I'm going to be connecting the output of the input here, if you can see my black pen appearing, to this through this resistor to the potentiometer. It's very simple how it works. So when we configure the analog to digital, or ADC, we're going to run a conversion, and then we're going to read that value as controlled by the potentiometer on that board, and we're going to display the results on the LED. So how do I know how it's laid out? I've got a very detailed description here. I'm connecting the potentiometer, a 10K potentiometer on RP1 through to, if you look here, through to RA0, which is actually called RA0 on the board, but it's also known as AN0 here. So it's very important that we get this address correct. So we're going to be talking to analog 0. So what we're going to do is we're going to initialize the board. That's set up the timers, set up the clock speed, set up the inputs and outputs. We're going to create a variable to store our ADC results. We're going to read the ADC, and then we're going, because it returns a value at point number 3 there, it returns a value of 0 to 255. We can use that to set the state of the LEDs, and we do it again. Let's look at that in terms of a flowchart. So here in the flowchart, we initialize, pretty automatic in Great Cow BASIC. We're going to create a variable, and then we're going to read that ADC, and it's a single command, and it's placed the current value of the ADC into our variable we previously created. And then it does a few things. It says if it's less than 50, set no LEDs. If it's between 50 and 100, set 1, set 2. If it's a different value, then set 3, and eventually set 4 LEDs. So it's a relatively simple process. So let's get straight in, and we're going to look at the example code, and then we'll review the results on the board. So let's have a look at some code. Let's review where we are, how we set up Great Cow BASIC, remembering that all the code here in green is comments to aid your understanding afterwards. We've seen this before, these two, and that's the chip statement, and we're using a 18FxxQ41, and option explicit means that we have to define all our variables. Well, we're going to be defining one variable, so that's important. A couple of constants we're going to set up. We set up a constant for the port of LED, a constant for the potentiometer. And what's important is I've used that constant as a reminder where I've actually put it. I might not use that in the program, but do you know what? It's quite useful to remember that let's have a look at the lab there. It's quite useful to remember where the ADC is connected to when you come back to your code. So I put that in there for just to so it reminds us where the code is. I have to set the LEDs to out because we're going to turn them on and off. They need to be digital out. Now let me just take you on a slight distraction from what we are, not distraction, but an education piece. In your Great Cow Basic installation, you will find a piece of software. It's on my desktop now, and it's called PICInfo. Very useful piece of software, and it lays out all the chips that we support in Great Cow Basic, a few thousand of them, and for the PICs, this is for PICs at the moment. And if I type in the part number of the one that I want to look at, I'm looking at the 18F16Q41. It tells me many different things about it. It tells me the configuration that Great Cow Basic will set by default. It will take me to the data sheet, to the errata, and the PIC web page, which is wonderful. It will take me to some utilities, which we'll look at later on in terms of PPS tool, etc. We'll look at those later on in the sessions. But what's important today is, how did we determine that RCO? How did I know that? Well, they're called bits, and it loads the bits up, and I can do a search in here for RC0. If I put a 0, it would help, and it takes me to RC0. So I typed it in, then I pressed the right hand mouse button, and it would take me to RC0. There it is, it's on the screen there, and we can see that equates to port C0, and it's actually a constant to port C.0, and there is RC1, RC2, RC3. So if you wanted to know a constant for a particular port, you weren't sure on it, you can always use this tool, because it will take you to two constants. It will take you to, there's a constant here called RC0, and is there a second constant? Let me have a look. No, there's not a second constant. So that's very good. So RC0 is the only constant for this. Now you could refer it to it in other methods, but this tool called PICInfo is extremely useful, so you can understand the constants that are defined in the data sheet. Okay, let's assume we've got the board set up. Let's do the actual ADC. Set up my a variable, and I use the dim statement. I create a variable called ADC value as byte. That's in the, so a byte is a range of 0 to 255, and we'll cover different types as we go through. I then read the AD, read the analog to digital port on AN0. That is the address that I should be using, and it puts that result in ADC val, the byte that we defined. And that is all we have to do in Great Cow Basic. It will do the rest of the setup of all the digital analog ports, the addressing, etc., and all the conversions for you. Then we have what's called a case statement, and that is our little flow diagram we looked at earlier on. It says select the case ADC, so that says, well, if the case is between 0 and 49, set no LEDs. If it's between 50 and 99, set one of our LEDs. 100 to 150, set two of our LEDs. 150 to 200, set 3 LEDs. And finally, as it can't be any other value, set 4 LEDs. That is the complete code. So if we look at that and we program it, remember I'm going to press the green hex and flash. It will assemble it, it will load it through the programmer, and it's set up 1 LED. Well, that tells us the value must be somewhere between 50 and 100. Let me just swing around and rotate that potentiometer. As I rotate the potentiometer, the LEDs are lighting exactly as predicted. Full off, that tells us the range must be between 0 and 49. 1, rotating, I'm rotating clockwise, anti-clockwise, 50 to 99 or 100. 100 to 149 will give us 2 LEDs. 3 LEDs must be 100 150 to 200, and finally the last bit will be 4 LEDs. So what we've got, look, is a very basic Knight Rider controlled through a potentiometer. So what have we seen? We've seen that reading the analog to digital with Great Cow BASIC is simple. We've looked at creating a variable. We've looked at how we create these constants and look up those constants in PICInfo tool. All very simple. Back to PowerPoint. So we wanted to do tutorial 3. I think we've done that. It's very simple. We've done the set up the LED to represent the value of the ADC. Now tomorrow we're going to bring a bit of tutorial 2 and into tutorial 4, and we're going to sequence the LEDs using a delay, and we're going to have that delay being the value of that ADC. So we're going to bring the two together and we're going to sequence the LEDs in a different manner. So, in this tutorial, enjoy.